Hi guys, it's Miss M here. I am not in my usual environment for two reasons. One, it's Saturday and I wanted to get this paper 2 corrected to you before your paper 2 exam. And two, psychology says that if our environment's a little different or a little weird, we're more likely to remember it. So I'm kind of hoping that you'll remember this intro, which might spark some of the answers on how to answer when you're taking the exam. Okay, so this paper that I corrected, it's paper 2 9990/22. It's February and March of 2018. So this is like one of the very first specimen papers that was ever created. It was never actually tested. So without further ado, I'm going to send you over to that, and you're going to see that it's only section A and B that are graded. I left C, which is design your own study. I left that for a completely different video. Now, if you're still prepping for paper 2, this is the number one thing you're going to want to study. Vocab, 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 strengths and weaknesses of those vocab. Okay, so basically you're going to want to know like the definition of ecological validity and 2 strengths and 2 weaknesses associated with it. You're going to see that a lot in this paper. So good luck, guys. And, you know, I so appreciate you subscribing to my channel. And if you don't subscribe, please do, because I not only put out psychology content for AICE, but psychology in general. I love the subject. Okay, I think I already said this, but let's head over to the video. All right, guys, this is the 9990-22 February, March 2018 paper. All right, section A, let's begin. So one of the aims of the study by Schechter and Singer's 2 factors in emotion was to find out whether the mood of a stooge affected the way the participants interpreted their arousal level. Okay, that's just an intro. Write an operationalized, directional, one-tailed hypothesis using the same. Okay, so I underlined operationalized because we need to make sure that we are defining our variables, and when I say variables, there needs to be both variables present, and then directional. So that's going to be directional or one-tailed. This is basically saying that variable A will be better or cause a better change or be faster than variable B per se. Okay, so the mood of the stooge, euphoric or angry, will increase the participant's arousal level. Okay. So, unfortunately, this is not going to get any points for a couple of reasons. One, this kind of is taking the shape of a non-directional, because we're not really saying that one is going to increase over the other. They're saying that both will increase, which is technically not a non-directional either. A non-directional would say something like there will be a difference between emotions and the stooge, which is not the answer here. We're looking for something along the lines of emotions will be rated as more positive with the happy stooge than the angry stooge. Okay, so we need to separate those variables, especially when we're doing a directional. Okay, because we want to say that you could have said either. You could have said that the angry stooge, you know, is going to elicit more positive. I mean, not really, because it's anger, but you know, whatever. You could have said they were going to elicit more negative emotions than the euphoric, whatever it may be. For a directional, you need to do one more so than the other. Okay, so we have a B to this. Write a null hypothesis using this aim. Now, your null is going to actually just be what you wrote up here. You're going to write it as basically that it's not going to happen, or that one is not going to be better than the other, or that one emotion is not going to cause a bigger change than the other. Okay? If you say something is just due to chance, that is basically saying that I'm going to have to say that is a non-directional. That's part of a non-directional hypothesis. Okay, so any difference between the mood of the stooge and the way the participant interpreted their arousal level is due to chance. Okay, so unfortunately this won't get any points, because this is basically how you do a null non-directional hypothesis. Okay, We need to say something more along the lines of there will be no difference in emotions between participants with an angry or a happy stooge. Okay, because we have to name those variables. We could say something like any difference in emotions between participants with an angry or a happy stooge is due to chance. Okay, that's different between any difference between emotions and angry or happy stooge is due to chance. Okay, I'll just make that clear. Okay, here in this answer specifically, they're comparing emotions with the stooge. Okay, we're just comparing any differences between emotions. Okay, all right, gonna move on. Number 2A, state the difference between a population and a sample. Okay, so we have the word state here. So this is 2 points. All right, you're just going to basically give us the exact definition of population and a sample, but make sure that you highlight that difference. Okay, so let's see what we have. A population is a group of people or animals with one or more characteristic in common. A sample is a group of participants who are taken from that population and should ideally be representative of that population. Okay, so we're definitely going to get a point there for basically saying that a population is all the people who could be used in the study. And then a sample is everyone who was actually part of the study. Okay. B, state one feature of the population in the study by milligram. Okay. They were from New Haven, Connecticut, just in case you wanted to know that. All right. That is definitely true. So many different characteristics for milligram. You could have said American, you could have said male, New Haven, newspaper readers, ages 20 to 50. You could have said they had a range of occupations. Okay, something like that. All right, number 3, name one sampling technique. Awesome. Random sampling. Perfect. All right, so, I mean, you could have had different types of sampling techniques, self-selected, opportunity, random sampling. Those are all different types. Explain one advantage of using this sampling technique. Okay, let me give you guys a hint. So if you find that you answered this and you said, uh-oh, I don't remember an advantage of this, you can go back and change your answer to one of the others. If you remember an advantage of, let's say you remembered an advantage of opportunity, that it was fast and easy and quick. All right, and you could ask the participants right there on the spot. But you answered random here. So go back and change your answer to opportunity and then write your advantage of opportunity here. Okay? Tricks of the trade. All right. Explain one advantage. Everyone in the target population has an equal chance of being selected, so the sample would be more representative and generalizable. Awesome. See how they tell me, okay, everyone in the target population has an equal chance of being selected. There's 1 point. So the sample would be more representative. All right. Another point. Perfect. It's kind of like when we do the PEE, point, example, explain. They only needed to point and explain. Okay. If you needed to keep going, you didn't have anything else to say, you can give an example from a study. All right. Saavedra and Silverman studied a boy with a phobia of buttons and measured his distress using a feelings thermometer. It's also called the hierarchy of needs, right? So we're going to name the type of data that is produced by the feelings thermometer. Okay, just 1 point. Quantitative data. Awesome. Okay, because we were giving it a scale, giving it a number. We were rating it. Remember that? Okay. All right, so we have a sub question of A. How did the feelings thermometer measure distress? The feelings thermometer was a 9-point scale ranging from 0 to 8. Oh, that'll just get the point right there. Great job. They did put some examples, but it's not really necessary. Okay. Suggest one disadvantage of using the feelings thermometer to measure distress. The feelings thermometer doesn't allow the boy to properly express his distress as it's limited to a number scale. This would lower the validity. This is perfect. This is awesome. I'm gonna get 1 point there for telling me exactly what the question asked and then telling me why it is a disadvantage right here. Just this little sentence right here gets him that other point. Okay, remember, we got to link it back to why it's a disadvantage. Okay, number 5. In the study by Bear and Comin, the AICE test, there was more than one control condition, which is true. There were all control conditions except for the autistic group. Identify one of the control conditions. The Cambridge University students. That is true. Okay, you could have said the normal adults from the library or the general population. That's one group. You could also have said the IQ matched group. Okay, B. Explain one reason for having a control condition using this study as an example. Okay, so let's remember P. Point, explain, example. All right. The control condition is designed to be equivalent to the experimental condition, except the independent variable is absent. So it provides a basis for comparison. For example, the autistic Asperger syndrome high functioning autistic group was compared to the rest of the groups which were control conditions. Oops, awesome. So they're going to this part right here. That's going to get that 1 point. So it provides a basis for comparison, having that control group. Okay, and then we have an example. Sorry. I'm not going to give that point because it's an example from the study of just saying what the control group was, but it's not an example for the reason of having a control group, if that makes sense. Okay, so make sure you're not just giving an example of what a control group is, but giving the reason of so we can provide the comparison. So maybe you would have said something like comparison without intervention, because basically we're talking about intervention in that sense. All right, we are on 6, and 6 is a 6-point question. So describe the differences between a field experiment and a natural experiment using any examples. Okay, let me give you a hint right now. If you know any studies that are field experiments or studies that are natural experiments, you're going to want to write them right away. Just write them on the side so you know, and you can go back and use examples from those studies specifically. You're going to want to do that. You can get points for basically describing any example or that contains a difference between those two. Okay, so let's see. A field experiment is conducted in the participant's everyday real life environment. All right. The experimenter still manipulates the independent variable, but just in a real life setting. Okay, I understand what they're saying. We may not have control of... All right, I'll come back to that sentence. For example, Pilyavin et al. Was a field experiment as it was conducted on a New York subway station, a real-life setting, and the independent variable was manipulated. For example, the type of victim used, drunk or ill. Oh, okay, I understand what they're saying here. Give them that extra point there for providing that example. Here we go. So, I mean, ultimately you could do PEE for field and natural as long as you're telling me the opposites of what you talked about. Okay, so we're basically looking for them to talk about it not being in real life, possibly, because that would be a difference, right? Let's see. In a natural experiment, the study is conducted in a real-life environment of the participants, but the researcher has no control over the independent variable. Okay. So we'll get 1 point here. For example, Baron Cohen, it was conducted in a lab setting, but is considered a natural experiment as autism is something naturally occurs. Okay, I mean, that is definitely a point there. We're kind of almost just missing a couple links in this question, you know, of exactly what is making, it's this first sentence that is the same. Conducted in a real life environment, conducted in a real life environment. That doesn't necessarily make these sound opposing. Okay, 1, 2, 3, 4, 5 on that one. Deepa is studying memory using a brain scanner. She is testing the hypothesis that there will be a positive correlation between level of brain activity and how much a person can recall. Each participant is asked to describe an event that happened more than 1 year ago. Name one brain scan that Deepa could use. An fMRI scanner. Perfect. 1 point there. I think you could have also said like a PET scan, which is the positron emission tomography, blah, blah, blah. Sorry, I think that's it. Positron emissions tomography, PET scan. Okay. In a previous syllabus, we had PET scans. B. Suggest why data from brain scans is likely to be reliable. Oh, we got to make sure we hit that mark. Why it's reliable. Okay, so we're looking for something like data is numerical, you know, so we don't have to interpret it. It's recorded by a machine, so it's objective, okay, because it's 2 points. So like we're looking for an if-then kind of statement. A brain scanner, such as fMRI scanning, is a professional piece of scientific equipment, which makes it very consistent in its measures, thus making it highly reliable. All right. We're looking for a link other than saying that it's consistent. Because saying something is consistent is saying something is reliable. So it's like saying that, like, scientific equipment is reliable, which makes it reliable. So something that would be better to say, I'm going to say is scientific equipment, which makes it objective, thus making it highly reliable, or quantitative, thus making it highly reliable. Okay, that makes sense. So, unfortunately, I'm not going to be able to give any points to this, okay? I'm asking how it's reliable, and they're basically just telling me because it's reliable. We need to add some different definitions in there that kind of relate to or correspond to reliability, but aren't those words, okay? So, B. Suggest why data from... Oh, I just did that. I'm so sorry. It's late here, guys. Sorry. Suggest how Deepa could convert each participant's description into a memory score. Count the number of words in their description. Okay, that's definitely going to get a point. You could have also said something like the time how long the description takes. Okay, that'll work too. D, explain whether Deepa will be able to conclude that greater recall causes more brain activity. No, she won't, because this is a correlational study. Awesome, because when we say cause, okay, correlations do not imply causation. Wonderful, meaning it's not possible to draw a causal conclusion, as there could have been a third factor that affected the brain activity recall. Ooh, good. Great job. Okay, E. Deepa considered asking her participants to recall a specific event such as their last birthday, but decided that this could be unethical, so gave them a choice about which event to recall. Explain one reason why this was a better procedure in terms of ethics. Okay. So asking participants to recall one specific event may be unethical, as participants may not want to share that information for any personal reasons. Giving them a choice is more ethical, as it would allow the participant to choose whatever they are most comfortable with, maintaining privacy. I think that is an awesome and very well written and complete answer. So they're saying they want to share information for personal reasons. So I'm going to give one there. Giving them a choice is more ethical. So we're giving an alternative, and it would allow participants to choose what they are most comfortable with, maintaining their privacy. Awesome. Okay, here's question 8. Hugo is using a questionnaire to find out about people's helping behavior in the daytime and at night. A, what is meant by open questions and closed questions? Okay, 2 points. So we're basically defining each one. Open questions are more descriptive, as the participants can write in their own words and give more detailed responses, whereas closed questions have a fixed set of possible responses. Great job. I'll take that. B, suggest one open question that Hugo could ask. Okay, make sure it's about helping behavior. Describe an example of when you have helped someone and the time of day. That's good. You don't need to put the time of day. I mean, just putting describe an example of when you have helped someone is an open question. C, suggest one advantage of using open questions in Hugo's study. Open questions allow the participant to say exactly what they want to say, as they're not limited to a fixed amount of choices. Awesome. So they're telling me that they can say what they want and that they are not limited to a fixed amount of choices. Okay, you can also say something like, you may not know why someone did what they did if you only have fixed choices. D, explain one problem that Hugo might have with the validity of the responses to his questionnaire. Okay, I mean, this is kind of goes with all questionnaires. This is why we need to know the strengths and the weaknesses of all of our vocabulary words, specifically questionnaires, labs, field experiments, observations, all these, interviews, everything. We need to know the strengths and the weaknesses, because when they say one problem, or like here, one advantage, okay, that's a strength and that's a weakness. So, I mean, that's a majority of this test. Open questions give a lot of detailed responses that have to be interpreted by the researcher. That is true. And so it is possible for the researcher to be biased in their interpretations. Let's see. Definitely. Lowering the validity of the responses. I almost want to ask, how specifically does this lower the validity? But I like how it's connected back to the original question. I'm not 100% sure if this 1 point would be here or not, but right now it's not going to make or break it. I would prefer something a little bit more detailed of how, specifically how a researcher being biased is going to lower validity. Okay. 9. Keelan has collected data about children's aggression. He has several types of data. In one experiment, Keelan recorded the number of aggressive acts per hour in children of ages between 3 and 18 years old. Name a type of graph that would be most suitable to display this frequency of data. Okay. The answer is a histogram. Okay, so we're not going to get points there. So the reason this is this answer is because a histogram represents the frequency distribution of continuous variables. Like, it would be like this. Okay, that is a histogram. Where a bar graph is, it's basically a comparison of discrete variables. So they're, you know, they're not going to be connected in that way. Okay. Like this bar chart here, like these are categories that are not related, if that makes sense, where this is frequency. Okay. B, label the axes for the graph that Keelan should use. Okay. So, the y-axis is always going to be what you're measuring. Okay. And think about your height. Like you measure your height. You don't normally, when you're standing tall, you measure your height. Maybe up on the wall or something like that. Okay. So dependent variable should be on the side and the independent variable should be here. Let's see. So the number of aggressive acts displayed per hour and the age of the children. Awesome. Awesome. So this is, I feel like I'm looking for this label too, because this is 3 points here. I mean, they're going to get a point there, a point there. So what I think is missing is the labeling of the groups here, where it says between ages 3 and 18. So like if you even said that, or if you wrote ages 3 to 18, okay, labeling that specifically, that might get you another point on there. Okay, sorry if you couldn't see that. There you go. Name one measure of spread that Keelan could calculate from his data. Range or standard deviation. Okay, here we go. Keelan also counted the total number of aggressive acts in categories: bite, kick, slap, and pinch. Name the measure of central tendency that Keelan should use for this data. So the mean is not the correct answer. It should be mode. It's the one most often used. Okay, so that's what we're looking for, the one most often used. We just don't have any numbers to add this up and divide it. So if this is all we know, right now. I'm going to say mode. Okay. I guess if you want to challenge that, you can challenge it. All right. Actually, down here, the next question says, state how Keelan would calculate this measure of central tendency. Okay. He would add up all the scores in each category and then divide it by the number of scores. See, that's the problem, though, is we have to connect this information back up here to this histogram. So unfortunately, once you start to get some of these questions wrong, and it kind of trickles down. Like, we're looking for frequency. So the ones that are most often occurring are the ones that, we're kind of looking for frequency. The ones that are most often occurring. We're not looking for means in that sense. Okay, so the mode makes the most sense here. And unfortunately, this is not the correct answer either. Okay, so this won't get points.